So hello everyone, so let's solve MEXT exam Math B 2013 question 3. Okay, so for this question I'm going to solve in the computer because I think I can't write in the computer, but I think that for this question it's more important for me to show you the graphs. Here we have the y-axis and the x-axis. Okay, so the question is telling you find the range of m such as this equation over here is equal to this linear equation. M of x is a line, right? Has four distinct solutions. So what does he want from us? Well, number one, we have a function x minus 3x plus what was it? 2 plus 2. So we have this function over here. This function, second degree function. The linear coefficient tells you where it cuts the y-axis, and you can solve with the second degree equation to find where it cuts the x-axis, right? So I will leave a link over here for this Google Drive where I take picture from my notebook where I am solving the questions. As you saw over here, I have some physics. I don't have them all yet, and here math, and this question is from Math B. I have all Math B of 2013. So question 3, it has all a part of itself. I think this question was I think it's until now from what I solved it, this must be the most tricky one, I think, maybe most difficult. So here you can see me solving it with me drawing, so that you don't need to have this graph in the exam. You can solve by yourself. Look, I solved the second degree equation over here. X1 is equal to 1 and x2 is equal to 2, and I know the linear coefficient, so I know that this part over here, and I found even the vertices over here, so this would be it. But notice over here in the question that you have it in a modular form. So what is when you have it in a modular form? Well, you can't have this part over here. This part over here is negative. Here this is the vertex. Okay, so this part over here is negative. We don't have it in our equation. So what we have is that this equation is in model. What is going to happen when I put in model? This part that is negative, it's going to reflect over here. It's going to become positive. You see? How was it? It was just this, and then it become when in the modular form, without the modular form. Okay, a simple second degree. When this is much easier to solve it with graphing. Okay, so but you can definitely do it like, look, from x, look to the second degree, from x smaller than 1, x smaller than 1, all the value of x smaller than 1, f of x is bigger than 0, right? F of x is the y-axis, and x is this one. Look, from 0 to 1, all of them are positive. Now, from x between 1 and 2, f of x is negative. So you would have to change the sign over here, okay? So here, this is what I'm saying. You have that this part over here, and it's going to reflect like this. The vertex was minus 1/4. It's going to become positive 1/4. The 3.2 will stay the same. Look over here. Look. You see? This point is just this point reflected in the x-axis. This is what basically our model says. So look, for this question we have three. We are going to draw the graph of this part, then draw the graph of the modular part, and then we are going to compare to m of x. So what do I mean with this? We don't need to use this purple one anymore, so the red one. Look, the question is telling you you want this such as when it's equal to m of x, it has four distinct solutions. Well, what is m of x? Let's say m of x. So this m of x is a line. You see, it's not squared, it's not cubed, it's the question of a line. So look, this m, when we variate m, look what happened with this line, the dark line. Look, it can go there. Look, 6.2, 6.1, 6, 4, 0, 0, it's in the x-axis, 3. So you see, this m is the angular coefficient. It manipulates where this angle is. So look, when it's over here, the m, how many solutions do we have? Well, 1, 2. Does this satisfy our condition? No, we need to have 4 solutions. So let's go bigger. Now that's bad, right? Because when we go bigger, we still have 2 solutions only. So let's go down. Look, now we have 4 solutions. Now it cuts over here, over here, over here, and over here. So now we have 4 solutions, and in any time this line had, look, now it doesn't have 4 solutions. So if it was like here, if we could find the tangent line that passes from 0 through this part over here, all the points below it have 4 solutions. Why? Because here we'll have 1 solution. Look, it doesn't, and it needs to be bigger than 0, right? Because look, if m is smaller than 0, then it doesn't cut anywhere. But if m is bigger than 0, then we're always having 2 solutions. We always have 2 solutions, okay? But if we want 4 solutions, we need to cut this part over here 2 times. So if we are tangent to this part, we are having 1 solution over here, second solution like in a tangent part over here, and the third solution over here. So we need to be smaller than the tangent line and bigger than 0, okay? It can't be smaller than 0, okay? So how do we go on finding this? Look, in the pictures, I say that this line over here, the purple one, it cuts 4 times, correct? The red one, it cuts only 2 times, and the green one is tangent, so it cuts only 3 times. And you need to notice that when it's tangent, it doesn't need to pass right through the vertex over here, okay? It can be over here. So the vertex has nothing to do with it. So let's go to part 2. So what was the next thing you need to think about? So this part over here, you need to find its equation, right? This part over here, why do we need to find its equation? Well, we need to find its equation because we want to compare it with this line in a form that we find it a tangent. So how do we find its equation? Well, we have 3 points, 1, 0, and you have this point and you have this point. So you can find this equation easy, and you have it over here actually. So when it's between 2 and 3, 1 and 2, it's going to be negative, right? So look, it's a modular function. When it's in the it's smaller than 0, you take it minus x squared plus 3x minus 2. You see? So it is this equation from where? From x bigger than 1 and smaller than 2. You see? If you solve it like a modular function, you will find this part. So this is the equation of this arc over here. And I'm going to say that this part over here is equal to m of x. M of x, okay? This part over here is equal to m of x. Why am I saying this? I'm saying it over here, okay? Saying, so this is the function of this part over here, I'm saying that it is equal to m of x. Why? Because I want to find the condition for it to be tangent. How is it going to be tangent? Well, when this equation over here minus x is equal to m of x, if we solve this second degree equation, our delta must be equal to 0. Why must it be equal to 0? Because we want it to be tangent. If it's equal to 0, then it has only one solution, and if it has only one solution, then it's tangent. If it has, like, look, here, m of x. So m of x is going, right? So look, if if this function equals m of x has two solutions here and there, then delta must be bigger than 0, right? If it has no solution at all, then delta is smaller than 0. If it has one solution, like I can't go in barely touching, it's barely touching, imagine the line barely touching. I actually have a photo of it over here. Over here. So the line barely touching, this green line, barely touching, then delta must be equal to 0. What delta? The second degree function. Let me just take this number over here. Y is equal to 3 minus 2. Okay. 3 minus. 1 second. 3. This is. I might be taking too long, but I think this part is really important. Like if you can't solve this question by yourself, it's because we're going to find this number, okay? Don't worry about it. So you see how this is tangent, it's cutting only in one part. This is the line that we were looking for, right? If we could find this line, if m was smaller than this part over here and bigger than 0, then we will have our condition. Sorry, wait. If m is bigger than 0 and smaller than the green line, then we'll have our condition that it's cutting 4 times, okay? So I need you to have the idea, and it's the important part. Calculating the calculus, you can do it, you are capable. So look, and the idea is whenever you have minus x squared plus 3x minus 2 is equal to m of x, and you want to find only one solution, then delta must equal to 0. This is the condition for you to be tangent, or you can do it by calculus, okay? Like, it's the same thing, to be honest. So if we try to find delta is equal to 0, we'll find this part over here, and then we will find that m, remember, just like as I said, m must be bigger than 0, m must be bigger than 0 and smaller than the green line, and you will find the green line by that equality over there, giving delta equals to 0. Now you will find two solutions, okay, to delta equal to 0. This solution over here is not valid. Why isn't it valid? Well, look, you just know that this m is really big, and wait a second. Look, remember that we put the condition over here for x to be smaller, but when we are comparing this equation, finding the delta of it with m of x equal to 0, we are not comparing only from x bigger than 1 and 2. This part over here is giving us different, like, look, if I take away this part over here and now I have the whole thing, it is tangent, it is still tangent, but over here in the bottom, okay? So I think this might confuse you in the middle of the exam, but you need to find that this m over here is really bigger than this one, and you need to have, like, the square root of 2 is 1.4 multiplied by 2 uh, it is 2.8 maybe, so 3 is still bigger than 0. Okay, so this is not a negative number. So yeah, let's just put our condition over here back. So 1 x smaller than 2. Yeah, so and now you have this m equal. Okay, so and now we solve the first part of the question. Well, for this part to have 4 distinct solution, well, m needs to be bigger than 0 and smaller than this number over here. Okay, this is what I'm saying over here. So for the second part, now for the second part is more numbers manipulations, and you can use shared relations, so it's not something that, well, you need to remember the relations of Jared. Like, if you don't know this, really look it up, because uh, it is the fourth question that I solve using this. Okay, so just simple number manipulation, nothing too much. And this is S of m. Okay, so não foi eu não. So here in this pages you'll find all the algebra manipulation if you get stuck in any point, so you can go with it. So for the part 2, he wants the S of m, that is this part over here, and you can go carrying with this pages and find it. So S of m will be this part over here. It doesn't have anything like thinking if it's all algebra, and if you get stuck, just look in the link. So this is S of m. Okay, so m squared plus 5 divided by 2. 1 second. So I'm just going to call m's as x, okay, just so that I can graph it, but it's m. Okay, divided by 2 over here. Okay, so now in the third question, when m varies as in 1, find the range of S of m. So remember, how does m varies? Well, m varies over here actually. M varies from smaller than 3 minus 2 multiplied by square root of 2 to bigger than 0. So when m varies from this, how does the S of m varies? So we have it over here actually. Question 3. Okay, so remember, what happened to the picture? M varies from bigger than 0 and smaller than 3 minus 2 square root of 2. So in the minimum case, so when m is 0, we're going to have that S of m is 5 divided by 2, right? 5 divided by 2 if m is 0. And when m squared is 3 minus 2 square root of 2, we will have it over here, algebra, and we'll have it over here. So look, this was our m. So our m varies from where to where? So 0 bigger than x. Remember, this is x, but it's m. Okay, I'm just doing so that we can write it over here. 2 to the 1 divided by 2. Okay, so this is our S of m. S of m is this one over here. We have it drawn over here too. This is our S of m. Okay, it is this one. When it's going to 0, it's undefined because we are not defining. It must be bigger than 0. and then when it's bigger than 0 it's barely 5.2. Okay, so it's barely 5.2. When so the S of m, it goes bigger than 5.2. It doesn't go equal to 5.2. Okay, it goes, I can't go down, later we'll download. So S of m is bigger than 5.2 and smaller than 11.6 square root of 2. Okay, so this is it.